Students, last class on this ground to ground projectile we saw the standard formulas, plus also we saw the standard concepts, and also we solved some example problems. Now in this class we will see some extra formulas. Now what are the extra formulas? Now these are the four extra formulas which you can see, which I want to teach you now. Also, we will also do some example problems based on these extra formulas. In addition, we will also see the extra concepts what we need to learn. Okay, first the extra formulas. Now take for example, these are the four extra formulas I want you to memorize. Now this is h equal to r by 4 tan theta. How we got it is, now if you can recall what are the standard formulas, I'll just write it now again. Standard formula is now time of flight t equals to 2u sine theta by g. Then the maximum height attained by this ground to ground projectile is u squared sine squared theta by 2g. And then the horizontal range formula is u squared sine 2 theta by g. And of course now the projectile curve or the path of the projectile equation of the parabola is given by y is x tan theta minus half g x squared divided by u squared cos squared theta. So then these are the four standard formulas which we learnt in the last class. Now the extra formulas also will be useful, because as you can see, and then as I told you in the last class, now the first formula is linking, that is relation between time u and theta. Then the second formula is linking h, u and theta. Then the third formula is linking r, u and theta. And of course the fourth formula is the coordinate x comma y in terms of linking u and theta. So now we will now see other combinations or being linked, or the relation between other combinations is given by this. Now we take the extra formula number 1. Extra formula number 1 is giving relation between h, r and theta. Okay, that is a new combination. Then what about the second extra formula is giving relation between h and t. Then the third extra formula, even though I am not given, can be made to give the relation between r, t and theta. But then now too many formulas I don't want you to memorize. Therefore I just kept it out of this list. Whereas whenever you want, you can actually now work it out. How is, now by means of now relating r, t and theta can be done by means of taking the first well-known equation and then substituting in this second well-known equation. Okay, therefore r, t and theta relation can be got if you want it. Whereas as I told you, I don't want you to overload by means of remembering too many formulas. Therefore I just kept it out of it. Next will be, now this equation is nothing but the curve equation, this fourth equation, where you know now if you just relate this u squared cos squared theta can be converted in terms of r. How? I'll just now show you how also. Now this can be now rewritten as equal to x tan theta is common taken outside minus now the g half g x squared by u squared cos squared theta as it is I written, and then the extra what I have not taken out I am going to do like this. Therefore now here one square is cancelling it off, and then tan theta is sin theta by cos theta, one can be removed and then replaced with sin theta. Therefore now 2 Sin theta cos theta is nothing but sin 2 theta. Therefore, u square sin 2 theta divided by g gives you r. Therefore, this actually becomes x tan theta into 1 minus x by r will be a useful way of remembering this projectile curve formula. Therefore, now I have now explained how these extra formulas have got all the four. Now, we will now go to what are the extra concepts which are involved in this. The first extra concept is to do with the same range r for the same u but different theta which we learnt. What we said was now for the same range r because it involves sine 2 theta term. Sine 2 theta is the same value both for theta as well as 90 minus theta. Therefore we get the same range. Of course, the speed of projection, initial speed of projection u remaining the same. Now for two different theta you will get the same range, whereas now the two different theta will give you two different times of flight t1 and t2 as well as heights attained, maximum height h1 and h2 like this. Okay, just look at this figure. Now the same range, whereas this is now lower time of flight t1, this higher time of flight t2 because this this theta is lower, whereas this theta is 90 minus theta will be higher. Therefore, sin theta is the term which is coming in the time of flight 2u sin theta by g, this one. Whereas now this becoming 2u of 90 minus sin 90 minus theta, which is nothing but cos theta. That's the reason why I said that sin theta is now becoming cos theta for the second angle of projection. Similarly, therefore, now the height formula is involving sin squared theta. Remember, recall that the height formula is h equal to u squared sin squared theta divided by 2g. Therefore, sin squared theta is for this particular h1 as well as h2. Now it becomes now sin squared of 90 minus theta, which is cos squared theta. Therefore, now the two times are different. One is lower, one is higher. Similarly, now the heights also are different, even though the range r is same. Therefore, this is the concept which we have already learned. Now we should also know about how to answer some of the questions based on this concept. Like for example, now the question may be now for the same u and for the same r, now height h1 and h2, which is more? T1 and T2, which is more? Now in this particular case of this particular figure, where it is now showing, now suppose now this now T1 is less, and then T2 is more. Similarly, height H1 is less, H2 is more. We should be able to answer this. That is a concept which I am now saying. Then the second this out of this what happens is now there are some relations which can be developed. What are the relations? You take this relation A, which is says h1 plus h2 should be equal to r max by 2. We already know what is r max. R max is the maximum range which can be attained by means of theta equal to 45 degrees. Therefore, now you put now theta 45 degrees in the sin 2 theta becomes 1. Therefore, the r max or the range max is given by u squared sin 2 theta becomes 1 divided by g. Therefore, now then what we are saying is in this case h1 plus h2 is nothing but u squared. Now the first one will be divided by sin squared theta divided by 2g, and then the second one h2 will be equal to u squared cos squared theta by 2g. Therefore, using sin squared theta plus cos squared theta equal to 1, this becomes u squared by 2g, which is nothing but r max divided by 2. Okay, therefore now that is a relation. Therefore now some question may be asked based on this relation. That is part A of this extra concept. Then you go to the part B of extra concept, which is nothing but range r equal to 4 times root of h1 and h2. Now you can do the same combination instead of now h1 plus h2 as the first formula. Now we are taking h1 into h2, that is the products. What happens is, what is the product is coming to? u squared by 2g is there, and then sine squared theta into cos squared theta. Cos squared theta. This is h1, h2. Okay. Therefore, now you take the square root of this. Square root of this is going to give you u squared. I mean, this actually becomes now u squared by 2g ka whole squared is h1 plus h2. Therefore, now it becomes u squared by 2g into sine theta cos theta. Now, this can be written as multiply by 2 and then divide by 2. So, what happened? And no, don't divide by 2 because already it is there now 2. Therefore, just multiply by 2. This becomes, and of course divide by 2 again in order to get this. Therefore, this becomes now u squared sine 2 theta by 4 4g, which is nothing but r by 4. Therefore, we are now able to prove h1 h2 equal to r by 4 or r equal to 4 root of 4 root of h1 h2. Understood? So now that is a relation. What is this b? Then the third relation is r equal to half into g into t1 t2. Let us see what is t1 t2. T1 t2 is to be u squared sine theta cos theta divided by g squared, because 2u. Okay, what is now t1 is 2u, similarly t2 is 2u cos theta by g. Therefore, this becomes not this is nothing but 2 into sine 2 theta. Therefore, now you have, therefore this is nothing but 2 times range by g. This is t1 into t2. Therefore, we now have range is equal to half into g into t1 t2 is a formula which will be quite useful in solving some types of problems. Therefore, this is now the extra concept number 1. Then we go to extra concept number 2, which is like this. I'll explain to you. Whereas this extra concept number 2 will come to later, because that will be useful only for JEE Main students. Because NEET students, for NEET students, this will be a higher level of difficulty. Therefore, no question will come based on this extra concept number 2. Therefore, we'll just postpone it until we finish what are the basic extra concept. Now go through now extra concept number 3, which I will now explain to you. Consider the projectile path. This is the ground. This is a projection velocity u, angle theta. Therefore, this is going like this. Then let us say now, after this is now t equal to 0 is a projection time. Then at t equal to t, let us say now this is the point P at which the projectile is there. That means now at this point the velocity is, this is v, let us say, at time t equal to t. Now as we know, now the horizontal component of velocity remains the same everywhere. This also is nothing but u cos theta. This also is u cos theta. Whereas the vertical component is becoming reducing because of gt, and therefore now it is going on changing. Therefore, now the velocity v is a vector sum of both the horizontal component u cos theta and the vertical component which is equal to vx. Vy is equal to, vx remains a constant as ux, which is u cos theta, whereas vy is u sin theta minus gt because of reduction by means of retardation g vertical down. Therefore, this becomes less and less and less as we go along. Now, supposing now the question may be asked is, what is the time t after which the velocity vector has turned through an angle phi. That means now initial angle of projection is, let us say now this horizontal, therefore this now going to be u. So I just draw a bigger diagram, vector diagram. This is u, this angle is theta. Now it has now turned through an angle phi, mean then the v vector is like this. This angle by which it has now come down is phi. Therefore now the question asks, what is the time at which the velocity vector has turned through an angle? This is the v vector. This is the u vector. Now as we know, now the horizontal component remains the same, in then you drop a perpendicular. This is u cos theta. Therefore this is the horizontal component of the velocity. Okay. Therefore then what happens is, now this is, what is this vector? This vector is the GT vector. Therefore I just draw now again a bigger diagram so it can be very clear. This is u vector and this is GT vector. GT vector, therefore giving u vector plus GT vector gives you the new velocity vector at time t. And what is the angle between them is phi. That means the initial velocity vector u has now turned down through an angle phi. What is the original angle of projection? This angle is theta. Therefore then what is this angle? Original angle theta minus the turned angle phi is this. What is this vector? This vector is remaining the horizontal component, u cos theta vector. Okay, let us call it as ux vector. Now then what is the relation connecting u vector, v vector and then gt vector? That is a triangle. Vector triangle is like this. This is u vector plus gt vector gives you v vector. Now we can use a triangular sine law of triangle, or using the properties of triangle, we can write now, let us say now gt is this side divided by sine of opposite angle. What is sine of opposite angle? Phi. This must be equal to, then you go to v vector. V vector is this side of the triangle. We are not talking about this triangle. Therefore now this triangle we use, now this side gt divided by sine phi is the first term that are written, equal to this side v vector divided by this angle. What is this angle is? Now this angle being 90, therefore this angle is 90 minus theta. Therefore we just write it again like this. What is this? Sine of 90 minus theta, which is nothing but cos theta, is equal to, what is now the third side is the initial velocity vector u. This u divided by this angle. What is this angle? This angle is therefore equal to now let's take the third side is u divided by, let me show you this. Now the third side is u divided by opposite sine of opposite angle. What is this angle? This angle equal to the sum of interior opposite angle with nothing but this plus this. This is 90 degree. Therefore now sine of, what is this angle? Theta minus phi. Therefore I am going to now write this is equal to u divided by sine of 90 minus theta minus phi, which is nothing but cos theta minus phi. Therefore now this is a relation connecting, let us say now u, v and gt. Therefore now, as I'll just now repeat what is the kind of question which will be asked is, there is a particle which is projected from ground with the initial velocity u at an angle theta to the horizontal. After what time the velocity vector turns by an angle, given angle phi. Okay, that is, now this is the initial velocity vector. this is a new velocity vector after time t. Therefore, now the angle by which now the angle between the initial velocity vector and the final velocity vector equal to phi. Therefore, what is the time at which this has now turned by phi is the first question. And then second question, if so, then what is the new velocity value, that is v. Now, we, as I said, we have now relation connecting this. Time is what is asked for. Therefore, initial velocity u is given, and then the angle, original angle theta projection, as well as the turned angle phi is given. Therefore, this u is known, and then theta and phi is known. Therefore, this part of it is fully known, and then sine phi is known because phi is known. Therefore, gt. Now g is known, therefore now t can be calculated. Therefore, the first part of the question was, what is the time at which it is turned by angle phi? This can be written by means of this equal to this. Then the second thing is, and if so, then what is the new velocity value? Now this can be written like this: v is equal to u cos theta divided by cos theta minus phi. Now this can be easily seen also here, because the initial horizontal component remains same throughout. Then u cos theta divided by cos of theta minus phi gives you a hypotenuse of this, okay, which is equal to the new velocity vector. So this can be easily seen as, this is now the horizontal component u cos theta divided by cos of theta minus phi will give you the hypotenuse values. Okay, that is relation here. Therefore, now this is the extra concept which you must be aware of, both the NEET people as well as the JEE Main people. Right. Then we come back to what is required only for JEE Main people is this particular concept which I will now explain to you. Look at this figure. Now this is the horizontal ground. Then projectile is projected with the initial angle theta with the initial velocity u. Therefore, this is now the curve which is traced by the projectile. Then this is the initial time is t equal to 0. Then after some time t equal to t, it has reached some point on the. So at time t equal to t, the projectile has reached this point here, which is coordinates x, comma y. Then already we know what is the relation between x and y by means of the trajectory equation, which I will now write like this. We already know that y is given by x tan theta into 1 minus x by r. Okay, this is a new formula which we have learned just now, and this can be written as x tan theta into r minus x by r. Okay, then what is y? What is y is x tan theta into r minus x by r, whereas now let us just look at this. What is x tan theta? X tan theta is this height. Why? Because this is x, this is theta projection angle, initial projection angle. Therefore, this is x tan theta. How do we get it now? We just now extend this particular initial projection angle theta like this, and then at x erect the ordinate. Therefore, this height is given by x tan theta, and therefore what is y is only this part. What is y is given by x tan theta, that is this height into this fraction. What is this fraction? R minus x by r. That means now I'm just saying now y divided by the x tan theta equal to r minus x by r. Right? Now this is the ratio relation. Now I can also say now what is y again? Y is equal to x tan alpha, where where alpha is the angle of elevation of the point P at which the projectile is there at time t equal to t. Time t equal to t, the projectile is there at this particular point P, whose angle of elevation is given by alpha. Therefore, y can be expressed as x into tan alpha. Therefore, let me just now write it like this. This is y equal to x tan alpha is given by x tan theta into r minus x by r. Okay. Therefore, now we have the relation here like this. This divided by this is this divided by this. Or other way of saying it is this divided by this equal to this divided by this. What is this is x. Now what is this height? This height will be half gt squared. Why? Because now this is, how do we get this y? How do you get the y value is, as you know, y value is the vertical displacement after time t. That means what you do is y is equal, vertical displacement is vertical initial velocity u sin theta minus half u sin theta t into half g. Let me just write it once again nicely. Y equal to u sin theta initial vertical velocity into t minus half g t squared at time t. Therefore then what is now u sin theta t? U sin theta t is a full displacement, vertical displacement, then minus half g t squared. That means this is u sin theta t minus half g t squared. Okay, that at time t. Therefore, this part of it is half g t squared. Therefore, we can also write this ratio relation as this by this equal to this by this, right? That's what is being written here. Now what kind of usual question will be asked is, now even in the past JEE or even the NEET, we had come across this kind of questions, whereas now NEET it will be a little bit high level of difficulty, whereas JEE Main is they can ask a question at this after time t. Okay, what is the relation between half gt squared versus y coordinate? That is this divided by this equal to this divided by this r minus x, this is x. Now there have been a usual question which is there, okay, in the books is like this. A bird is sitting on a tree top. A bird is sitting on a tree top here, and then you are aiming a stone at the bird. Therefore, elevation angle is theta, and then you are throwing it at a initial velocity u, aiming at the bird. Then at the time of release of the stone, if the bird free drops itself from that height, okay, therefore it's just coming down free drop. Therefore now you must prove that the stone will always hit the bird, because the stone will take this projectile path here. By the time the stone reaches here, the bird should have dropped here is the proof which you'll have to actually do. Now this is now very simple, because at time t equal to 0, now the stone is here and the bird is here. At time t equal to t, because now the bird is free dropping, it has covered a distance of half gt squared as per this. Then also now the stone has moved to this point by that time t equal to t is what we have now proved here, right? Therefore now both will meet at the same point, which means now the thrown stone will hit the bird is what we have proved based on this. Now this 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 is a usual question which will be available in all the books also. Therefore, now the proof of it is by means of this particular concept what we have now explained. Okay, then there is one more concept which is only for JEE Main, which is radius of curvature. Consider this projectile motion, path of the projectile is like this. Then this is the initial projection velocity u at an angle theta with the horizontal. Then the question usually is, at any point during its travel, let us say now at this point, what is the radius of curvature of the path? Now the meaning of radius of curvature is like this. Now assume this path at this point is a part of a circle. Then what is the radius of the circle is what the question, what it means by radius of curvature at that particular point. It may not be a circular path, whereas now what is my radius of curvature is what is the, assuming that particular small part of the arc as ds as part of a circle, then what is the radius of the circle? Okay, now that is a question like this. Now how to find a radius of curvature of any curve at a particular point is like this. Now let me just explain what is the concept of the radius of curvature involved for any curve like this. Suppose now this is now a part of a curve, and at this point we want to find what is the radius of curvature is, that we have to treat now the small arc as part of a circle, that is approximate this curve to a circle at this particular small arc here. Now at this point the particle has got a velocity, let us say v, which is nothing but the tangential velocity at that point. Let us call it as v is the tangential velocity at that particular point, that is instantaneous velocity of the point. Then at this point it has got a acceleration. Now in the case of a projectile, we know acceleration is vertical downwards is g. Now we should find out what is the component of g perpendicular to the velocity vector at this point. Now this is a velocity vector tangential to the curve, therefore then perpendicular to the velocity vector is like this. Therefore this is called as a radial direction. Therefore we should find out what is the component of this acceleration g along the radial inward direction, and then we are going to actually compute it as centripetal acceleration. Why? Because suppose the component is something, then the component serves as a centripetal acceleration for a assumed circular motion of the particle at that particular point. Therefore now we have to find this particular, what is the radial component of the acceleration g. Now let us call this angle as theta. Then what is, no, let's call this angle as phi, because now theta will be a projection angle, that we will not confuse. Therefore let's call it as now phi. Okay, angle phi. Then what is the angle phi is between the vertical and the perpendicular to the velocity, which will be now the same as the angle between a horizontal direction and the velocity vector. This is now same, because horizontal and the velocity vector is angle phi mean, then the vertical, which is nothing but 90 degrees to horizontal, and the radial direction with nothing but 90 degrees to the velocity vector also will be phi. Therefore that is the concept. Therefore then we know that then what is the velocity v in terms of horizontal component u cos theta. This is u cos theta remains constant. This is a v vector, and therefore this angle is phi. This is now u cos theta, because that remains the same. Horizontal component of velocity remains same everywhere. Therefore v is given by u cos theta divided by cos phi. Therefore we use this relation and then say then what is the centripetal acceleration is v squared by radius r is a centripetal acceleration. Now in this case this must be equal to the component of g along the radial direction, which is g cos phi. Therefore r becomes v squared by g cos phi. And then what is r become v squared by g cos phi. What is cos phi from here? Cos phi is given by v by u cos theta. Therefore, we just replace cos phi by v by u cos theta. No, or rather, sorry, this is u cos theta by v, because cos phi is u cos theta divided by v. Therefore, v square divided by g into u cos theta by v. Therefore, it becomes v cube. Ultimately, we have this relation. Radius of curvature of the projectile at any point is the instantaneous velocity cube divided by g u cos theta, where u cos theta is the horizontal component of projection, and then g of course is a gravitation, acceleration due to gravity. Therefore, this particular formula is important. This kind of question will come for JEE Main. Okay. Now the standard question which will come is, what is the radius of curvature at the topmost point of the projectile, which is nothing but topmost point you have v is equal to at topmost point v equal to u cos theta again only. Therefore, r becomes u cos theta cube divided u cos theta becomes u cos theta u squared cos squared theta divided by g. Okay, which is nothing but, now at the topmost point, what is the velocity, which is u cos theta, is then the centripetal is g, which is fully is g vertical down. Therefore, u squared cos squared theta by g gives you centripetal acceleration. Therefore, this gives a radius of curvature at the topmost point is a usual standard question, whereas it can be asked for at any point also. Okay. Therefore, instantaneous velocity we can calculate v, then the formula can be applied. Radius of curvature is given by v cube divided by gu cos theta. Therefore, this formula needs to be memorized for JEE Main people. Next concept and the formula we should understand is a horizontal projectile. Now, so far we had covered ground to ground projectile. Now we will take up projected from a particular height and then horizontally. Let us take, for example, this is the ground level, and then there is a building of, let us say, height h, and then a stone is projected horizontally from the top of the building. Horizontal means now this is the initial velocity u is horizontal. Therefore, it is going to take a, because it is subjected to g vertical downwards, it will take a parabolic curve like this and then fall and then reach the ground. Then we are supposed to find what is this horizontal range, that is from the foot of the building to the point where the stone falls, and also what is the time of this flight, time t. Now it becomes very simple. Now we have now the horizontal direction equation is now ux equal to vx, because there is no acceleration involved in this. It is nothing but the initial velocity u. And then for the vertical downward direction, we will take now downward direction as positive for our calculation. We can write vy is nothing but g into t, because initial vertical component velocity equal to 0, therefore g into t at any time. Then what is now the time? Now the displacement equation is, now in this case, this is now x is given by u into t, whereas y is given by, because initial velocity is 0, therefore it will be half gt squared is going to be the equation for y. Therefore, then what is the time of flight? T is when y coordinate becomes equal to h. That means we know already from this, we know that t equal to root of 2h by g. Okay, why? Because now substitute for y h becomes 2h by g, therefore square root of 2h by g. Therefore now put it into this equation, you get the now the range is at range is the x value at time t equal to the time of flight, which is nothing but x value at t equal to root of 2h by g. Therefore this can be written as equal to u into root of 2h by g is the range on the horizontal. That is the range means the distance between the point where the stone falls from the foot of the building. Right? Now these are the relations which are given here. Then we also should be able to make out what is the velocity at any point during its flight. Let us say now at this point. Now what is the velocity is going to be given by what is the velocity here is going to be given by horizontal component of velocity u plus vertical component is equal to g into t. Therefore this is going to be the velocity v at any time, or rather we can write this as v as square root of u squared plus g squared t squared. Correct? No? Right. Then what is the velocity when it reaches the ground? When it reaches the ground mean then v equal to root of u squared plus what is now the g squared into t squared. What is t squared is equal to 2h by g. Therefore this becomes velocity when it reaches the ground is root of u squared plus 2gh. Now already we know this relation can be even derived from the energy angle, because at the topmost point the kinetic energy is half mu squared. Then what happened? What is now the increase due to the potential energy is mgh. Therefore then the final kinetic energy when it reaches the ground can be written as half m initial kinetic energy plus mgh. Therefore from here also one can derive that the final velocity when it reaches the ground is equal to square root of u squared plus 2gh. Right? Agreed. Now this is a formula which is there of course for a horizontal projectile. You don't have to really memorize this because you can easily derive it on the spot during your exam when you are faced with a question on the horizontal projectile. The next concept and the formulas we'll have to cover is projectile projected so that what is the range along an inclined plane. Okay, that is assuming projectile is projected from the foot of the inclined plane. Let me just explain this from this figure. Look at this figure. Now there is a inclined plane like this. This is horizontal ground. This is an inclined plane like this. Therefore now projectile is projected from the foot of the inclined plane with the initial velocity u like this at an angle theta with the horizontal, and the inclined plane angle of inclination is given as alpha. Therefore now over the inclined plane what is the projection angle is theta minus alpha, which is theta minus alpha over the inclined plane direction, and the initial velocity is u. Now with this, now the questions asked are when it hits back the inclined plane again, what is the time taken? What is the and therefore now what is now the time of flight? What is the time of flight for on this over the inclined plane, and what is the maximum height reached, and also what is the range r dash along the inclined surface. Therefore this is now the range. Let me just write, this is the range, this is the time of flight to go like this, and of course maximum height is nothing but if you draw a parallel line to the inclined surface like this at the top, what is the distance between the parallel line and the inclined surface? That is called the maximum height reached over the inclined plane. Correct? Now these are the formulas which already I have now written down like this. Now the derivation is very simple. Here what we need to do is now during the flight, first we will now take up what is the time of flight as well as h. Now like this. Now the the acceleration due to gravity is vertical down. Therefore, if you now take the component of the acceleration perpendicular to the inclined plane surface, then this becomes g cos alpha is the component of the vertical acceleration downward g perpendicular to the inclined surface. Therefore, now this is g cos alpha. Therefore, now the time of flight is going to be what is the vertical component of the velocity. Velocity is u. Therefore, now the initial velocity u, let us now resolve into two components. One is parallel to the inclined surface and the perpendicular to inclined surface like this. Now we just consider only the perpendicular surface because now the time is going to be determined by the perpendicular component only. Therefore, then what is perpendicular component is nothing but u into sine of angle over the inclined plane, which is now theta minus alpha. Correct? Therefore, perpendicular component is u sine theta minus alpha. Now, therefore, now what is the time taken to become now 0? That is when it is at the maximum height over the inclined plane, we are going to be 0, which is nothing but u sine theta minus alpha divided by, then what is the component of g pulling it down is g cos alpha. Therefore, this much is now the half the time of flight to reach the maximum point. Then again another half time to reach the inclined plane surface again. Therefore, not twice of this. Therefore, this is a formula for time of flight over the inclined plane. Therefore, then very similarly, then what is now the h is nothing but now using the displacement equation, which is nothing but half g t squared. Therefore, this is half into g into t squared. If you just do this, this is the formula for maximum height over the inclined plane. Then how to find the range r dash over the inclined plane? That is the distance between the starting point as well as now the falling point on the inclined plane. Now this can be done in a different manner. How? Let us find out what is the along the horizontal direction, what is the x coordinate when it has hit the inclined plane. That is this is now the horizontal direction. We are going back to horizontal vertical like this. Then we know that this is now the x coordinate is when it hits the inclined plane. This is now x. Now we already know that how to calculate the x is very simple, which is the horizontal component of velocity u cos theta into now the time of flight capital T, which is given as now the time at which it is hitting the inclined plane. Therefore, into t. Therefore, this is now the x component, which can be easily got as u cos theta into this time of flight. Already we have derived it this much. Therefore, once you have got the x value, then the r dash is given by this x divided by cos alpha. Okay, you can see that r dash is x divided by cos alpha will give the hypotenuse. Therefore, this can be easily got, and then once you do this exercise, you will get this particular formula. Now, it is better that JEE Main people memorize all these three formulas because it becomes very simple. Now, the T and H formulas are very simple because this got the same kind of format as a ground-to-ground projectile. Only thing is now the T for ground-to-ground is 2u sine theta by g, whereas now this is now 2u sine theta minus alpha is the angle over the inclined plane, and then g cos alpha is the component of g along perpendicular direction to the inclined plane. Therefore, this can be easily remembered. And similarly, now h is nothing but half g t squared. Okay, h is nothing but half g t squared of this This can be easily remembered. This also is very similar to the ground to ground formula, which is nothing but u squared sin squared theta by 2g, whereas now you have the same this thing as theta minus alpha is the angle over the inclined plane, can be easily remembered, plus now g cos alpha is the component perpendicular to the inclined plane. Therefore, this can also be remembered like this, whereas now this formula can also be remembered like this, because r dash is u squared 2 sin theta cos theta is for ground to ground. Now here it is going to make only a change that sin theta minus alpha, that is over the inclined plane, whereas cos theta remains the same. Therefore I just repeat now. Now in the case of ground to ground, then the R range formula is a u squared 2 sin theta cos theta. Here it is going to make only a change on this angle theta minus alpha for the sine. Cos theta remains the same, and of course now divided by, instead of g in the ground to ground formula, you have to have g cos squared alpha. Therefore now either now remember this, or because such kind of a questions on the inclined plane is going to be very rare, therefore you can afford to take a little bit time extra during the examination, and therefore you can actually work it out in the same way as what I have now done. That is, x coordinate along the horizontal direction you can compute by means of using this u cos theta uniform velocity into time of flight t. Time of flight formula anyway you have memorized it. This you can find. Once you have found the x value, then the r dash is x divided by cos of alpha. Therefore that can be easily got. Therefore you don't have to memorize this, really speaking. You can actually derive it on the spot. Now then of course now the maximum, what is for maximum r dash. Now similar to a ground to ground, you have the maximum angle of projection is r max can be got at an angle of projection theta equal to 45 degrees. This point you know. Now here only change is, now when you do the differentiation and then equate it to 0, you get the r max can be at theta is not 45 degrees, 45 plus alpha by 2. That is, I just repeat now. Now for maximum r dash getting, you have to have the theta is 45 plus half of the inclination of the inclined plane, half r equal to plus alpha by 2. Okay. Therefore now this is what it is, and therefore now putting this particular theta into the formula for r dash, you can actually arrive at this r dash max also. Right? No, fine. Now one more last aspect is, suppose now the question is that you are not throwing from the foot of the inclined plane, you are throwing from the top of the inclined plane. That is reverse direction. Suppose you are now throwing it, then what are the formulas undergo changes? Very simple, as I have now given here. Now is the projected is down the inclined plane rather than up the inclined plane. That is from the inclined plane, from the top, you just throwing it like this, then reaches here. Then what are the formulas for the time of flight to t and maximum height over the plane, as well as the range r dash along the inclined plane? This can be got by simply taking these formulas and the substituting, instead of alpha you have to put as minus alpha. That's all the change which you need to make. Now such questions will be very rare, and I suppose you may get it only in JEE Advanced type, that is down the inclined plane. Up the inclined plane itself is going to be a rare question for JEE Main, and then on the down the inclined plane you are likely to get never on the JEE Main paper, whereas you are likely to get it only in the JEE Advanced also, that too only a very rare question. But then if and when you get such a kind of a question, you simply take the formula for up the inclined plane and replace alpha with a minus alpha. You get all the formulas revised as per down the inclined plane. Okay, now this is what it is. Now the next concept we will have to revise, we will have to go into is now generalized motion. That means it's not a projectile, it is some on a xy plane motion of a particle that can have acceleration both along the x as well as the y direction. And also now acceleration can be even a varying acceleration, varying with time, not necessarily only constant acceleration. it can be varying acceleration, varying with time. Therefore, what is now the generalized procedure for number one, calculating velocity after any time t, as well as what is the position vector, that is xy coordinate after any time t. That particular method we should be able to understand now. That is going to be our next aspect. Let's go through the generalized 2D motion, how to calculate. Let us take now the initial velocity u can have x component as well as y component like this, ux I cap plus uy j cap. Then the acceleration, as I said, can have both x direction, y direction also. Therefore, write it as a acceleration vector is equal to ax I cap plus ay j cap. Then v at any point of time t is given by v equal to initial velocity ux plus ax t I cap plus uy plus ay t j cap. This is our this thing. Assuming now assumption is if it is a constant acceleration. If it is varying acceleration, then we have to do the integration. Okay, that can wait. Then assuming it is constant acceleration, which many problems can also have constant acceleration. Therefore, we can use this particular formula, which is v equal to u plus at formula in terms of vectors. And of course, now then the position vector, that is x I cap plus y j cap, is as per usual formula, which is the equation of motion for displacement, which is given by ut plus half at squared. In terms of vectors, then this is the ut plus half at squared for I cap plus for j cap. Therefore, it is like this. Now, supposing now the reverse problem is, now usual problem which will be given is, now position vector is expressed in terms of x coordinate as a function of time, y coordinate as a function of time. Now in this case, in this kind of a generalized case, now you can have not only constant acceleration, you can also have variable acceleration, which is like this. Now take this position vector at any time t is given by this as a function of x as a function of time, y as a function of time. Then how to find the velocity vector any time is now dr by dt vector, which is nothing but the dx by dt I cap plus dy by dt j cap. This gives a velocity component along the x direction. This is the velocity component along y direction, vx and this is vx, this is vy. Then how to find the acceleration is again now differentiate the velocity vector like this. Therefore, d squared x by dt squared I cap plus d squared by dt squared j cap. Now, when you work out, we will definitely work out some of the examples, and that time you can understand it much better. So now this is what the extra formula as well as extra concepts coverage. We have done enough exhaustive coverage of this, exhaustive coverage of the extra formulas as well as extra concepts, so that now we are in a position to practice some example questions, applying the concept what we have learned, applying the formulas what we have learned. And also now I had given the more than after going through the example workouts, you can also, I also have given enough PDF of the past asked question, both in terms of NEET as well as JEE Main. Now I am giving the question numbers for your practice, which you can use for practicing what you have learned. Now this is now the questions like this. Now, as I said that there many questions are common level both for NEET as well as JEE Main, whereas some questions are essentially only oriented towards JEE difficulty. Therefore, that I have given in the those questions are given in the red colored ink. Therefore, that is only for JEE Main people can practice those questions. Otherwise, all people NEET as well as JEE Main people can practice the black colored question numbers. Okay. Now this is no exhaustive list, and then all these questions are actually past year asked questions right from 2025 onward backwards. up to 2000 year. Okay, therefore you have sufficient number of questions for practicing. Now let us now take up some example questions for practicing. I'll tell you about approach how to apply what you have learned into these questions, and then as per usual procedure, what you can do is you just read the question and then pause the video and then try for yourself, and then if you are able to succeed or not able to succeed also, you can just go through. Afterwards you can play the video, resume the video playing, and then listen to what my solution is, and then check with what you have done is the same way, or I'll be able to tell you some sort of a shortcuts also wherever it is required. Therefore you can understand that way of solving.